Hi guys, today's Leetcode daily is count the number of complete components. So we are given an undirected graph with n vertices. Now we are also given a 2D integer array edges where our edges of I is equal to ai vi. That means there is an edge between node ai and bi. Now we have to return the number of complete connected components in this graph. So a connected component is a subgraph in which there is a path for all its vertices, and none of its vertices share an edge with a vertex outside of the subgraph. Now, this connected component will be said to be complete if for all its distinct pair of vertices there is a unique edge. Now, we'll see example to understand this question in a better way. So like this is the given graph. Now if we'll go to first component, then for 0 and 1 there is edge, 0 and 2 there is edge, and 1 and 2 also. So for all the vertices there there is unique edge. So we'll say that this is complete component. But in this component there is no edge for between 5 and 4. So this is not complete component. So here we have only one complete component. So we'll return 1 as our output. Now if we'll see that if we have a complete subgraph, then if it has n nodes, that means here we have 3 nodes, then number of edges will be given by n into n minus 1 by 2, that is 3 into 3 minus 2, that is 2 divided by 2 equal to 3 edges. This we can see, like we can feel also, like if we'll take 0th edge, it will have 0th node, it will have it 2 edges since it is connected to 2 components. If we'll take 1th, then it is already connected to this, so one more we'll need. That is, if we have n nodes, first we'll pick one node, then it will get connected to n minus 1 nodes, then we'll pick second node, it will get connected to n minus 2 nodes, and last node will get second last node will get connected to the last node. So we'll get a series 1 plus 2 plus 3 dot 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 up to n minus 1. So sum of this series is simple, n minus 1 into n by 2. Now we'll see approach. So we have already seen for a complete graph with n nodes, it will have n into n minus 1 by 2 edges. So we'll simply apply DFS and find out what is nodes count and what is edges count for each component. When DFS will end for a component, we'll see if these nodes count and edges count satisfy this condition or not. If they satisfy this condition, then we'll increment our answer by 1. Now for any node, how we'll find out how many edges it have? So it is simple. It will have edges equal to n- its neighbors in the adjacency list, because for every neighbor it will have one edge. Now if we'll find edges by this method, since it is given that we have undirected graph, so edge count will be double. So in our case, we should get edge count equal to n into n minus 1. Now we'll see code. So first we'll form the adjacency list. So we are simply traversing in edges vector, and for since this is undirected graph, so for every edge between A and B, there will also be edge between B and A. So for A, if we are pushing in its adjacency list B, then for B also we are pushing in its adjacency list A. After this loop, we'll get the adjacency list. Then we are taking back visited vector of n size, initially all the nodes marked as unvisited. In this answer variable, we'll store our answer. Now we are traversing for each node. If it is not visited, then we'll call DFS function to calculate nodes count and edges count. If edges count and nodes count satisfy this condition, then it is a complete component. We increment our answer by 1. After this loop is done, we have visited all the components, and all the complete components count will be stored in answer, so we'll return answer. Now we'll see implementation of DFS. This is standard DFS implementation only. where we are passing adjacency list node, and nodes count and edges count extra we are passing because we want to calculate that, and visited vector. So at first we are marking the node as visited and adding this node in our component. So we are incrementing our node count by 1 and incrementing edges count by number of neighbors for this node, because for every neighbor we'll have one edge. After that, we are visiting for all its neighbor nodes, that is all its adjacent nodes. And if it is not visited, we are calling DFS for that. Now, if we talk about time complexity, then this loop is running for big O of E, like if E edges are there, and the and this is standard DFS only. So for standard DFS, we have time complexity big O of N plus E. So overall time complexity is N plus E. Now, if we talk about space complexity, in adjacency list for every node we are storing all its neighboring nodes. So it is big O of N plus E, and this is big O of N. So overall space complexity is big O of N plus E. If you have understood this question, then please like, share and comment on this video and subscribe my channel for more such videos. Thank you.